Very good afternoon, everyone. Just confirm audio video is clear. Kindly confirm audio video is clear. Kindly confirm audio video is clear to you. So, hello everyone, myself Prateek Mishra and I welcome you all to the YouTube platform of IMS Gate Academy. We are conducting the foundation series of environmental engineering. We are discussing the basics of environmental engineering that will directly help you to solve highly conceptual questions. Yesterday we have seen the basics of environmental chemistry, my dear students. Those basics are very important. If you get any question from alkalinity, hardness or pH, definitely those basics will going to help you to solve these questions. And when you read the entire topic, you will find out that the area from where the questions are framed is only by using those basics. And today I came up with one of the again exciting lecture of foundation series of environment, and that is the sedimentation analysis. This is the second key area, my dear students, from where we are getting regular questions. And today, my approach will be to give you the basics of sedimentation analysis so that when you read this in detail, you have some basic thought process in your mind that how things are going, how we need to develop this concept and how we need to approach the question if any question is asked from this concept. So by these words, I would like to make few announcements first. My dear students, the Telegram group link is given in the description box. You can join our Telegram group to enjoy the daily quizzes, to get the lecture PDFs and the session schedules of our YouTube series. And also if you want to get the PSU job notification, again we regularly provide you in terms of video or PDF everything fine? Okay. We provide in terms of videos and PDF of the regular job notification of PSUs and also for other government examination. Also, we regularly conduct seminars and webinars regarding the new opportunities for engineers coming up in our country, and the links of these seminars and webinars we usually provide in the Telegram group. So again, the link is given in the description box. You can join our Telegram group. Moving ahead, next, we at IMS Gate Academy, my dear, we provide you with 4 different types of courses where we provide 800 hours of live teaching with interaction with doubt solving. We provide you with theory and exercise book, and especially in our exercise book, there are more than 4,000 practice questions, my dear, which are well placed in level 1, level 2 and level 3. Just imagine if you are doing 40 questions in a day, you are doing like 1600 question in every month. And if you are doing 1600 question every month for next 8 months, you will require more than 5,000 questions, and that too actual good quality practice questions. So this need of questions will be fulfilled through our exercise book, where we provide you with 4,000 plus practice questions. Along with that, we provide you with the GATE question bank. If you are from civil engineering stream, right? In our GATE question bank, there are more than 2,300 GATE questions, which include GATE questions from last 34 years. We have included all the questions. So in total, you have a total practice material of more than 7,000 questions with you, because here 2,300 GATE technical questions for civil engineering. Along with that, you have more 2,000 practice questions for mathematics and aptitude. Again, a separate book of GATE PYQ is provided to you. So we basically provide you with 2 GATE question bank, one dedicated for civil engineering and another one dedicated for maths and aptitude. And in this maths and aptitude book, there are maths and aptitude questions of GATE of all the branches. In our GATE question bank, we provide you with the detailed solution, we provide you with the alternate solution, and we also provide you with the video solution along with key points and chapter overview. We provide you with 12 personalized one-to-one mentoring sessions, and I proudly say that IMS Gate Academy is the only institute in the country to provide personal mentoring to our students so that they are oriented and well prepared and well planned for their entire journey of 8 to 12 months for their GATE preparation. We provide you with India's largest test series, which includes more than 130 plus tests, is starting from the chapter test, subject test, multiple subject test, advanced subject test, and the full length mock test along with the video solution. So if you look into the total practice material that we are providing to you, it is almost 9,000 to 10,000 of GATE questions and practice things. So this is what we offer at IMS GATE Academy. So by these words, I would like to begin my today's session, and my dear students, I promise you that if you hear this session very carefully, it will definitely going to help you to get at least 2 marks in your examination, at least minimum. Every alternate year we are seeing question from this segment. It's one of the very, very hot segment of environmental engineering, and not just for civil engineering students. If you are appearing in second paper as environment, again this area is very important. Reason is, if you look into the treatment of water, the basic thought process in the treatment of water is we need not to invest much amount. Okay. If everything happens automatically without addition of any chemical, that is the most economical treatment that we can give. And while we will going to discuss this entire process of sedimentation, you will find out that hardly any money is involved in this. And without investing any money, you are treating water properly. That is why this process is so important. Doesn't matter whichever place you are, the water that you are getting for drinking process, right? That water has undergone through this sedimentation analysis. Okay, leave that thing also. The unit that you have in your house, which you called as RO, right? Or a water filtration unit or a water treatment unit. Basically, it also has one chamber in which this sedimentation is also going. So when we discuss this entire course of environmental engineering in our classroom, I personally give them each and every example of day-to-day life so that the students can practically relate how these operations are taking place in the real life. Now, before understanding these operations, you should know the primary basics of these operations. So by these words, I'll start with this session. So my dear students, you have first calculated the quantity of water required for the community, that is your water demand, and using population forecasting. Once you know the total quantity of water required in a community, you have identified different sources from where you will going to fetch this water. Once you collect this water, second thing is you need to analyze the quality of this water. So the quality of water is analyzed using water quality parameter. For example, a river is flowing and you have fetched some water from that river. First you will going to analyze the quality of water. Now depending on the quality of this water, you need to provide treatment to this water. Now the question arises, how much treatment? How much treatment we should provide to this water? Sir, is there any standard method or across the country do we provide same kind of treatment? Now think on this. You have different rivers and lakes and ponds and seas and oceans and even the underground water from where you can extract the water. Is the mechanism of treatment same? Is the degree of treatment same? So you need to understand this. These are two terms. First one is mechanism of treatment and second one is the degree of treatment. Mechanism includes the different operations and degree of treatment means how much amount of operations you are doing. So as we know that the quality of water obtained from different sources of water will be different. Therefore, the degree of treatment given to the water will also be different. Just for an example, yesterday we have discussed suspended solids, total solids and dissolved solids. For example, the water that we have taken out from a river, it contains 600 milligram per liter of total solids. The water that we have taken out contains 600 milligram of total solids. 600 milligram of total solids. So this quality of water is the existing quality of water, right? Now Central Pollution Control Board has already defined the permissible limit of all the water quality parameter. Right now if I am talking about total solids, so the concentration of total solids that you got from this existing raw water is 600 milligram per liter. Now as per IS code, the permissible limit of total solid is defined as 500 milligram per liter. Means in your drinking water, the concentration of total solid should not exceed 500 milligram per liter. But you see here, right now it is 600 milligram per liter, but it should not exceed 500 milligram per liter. So we need to treat this water, and in this treatment what we do? We basically bring all the values of water quality parameter within the permissible limit. Means we need to treat this water to bring down the value of total solid from 600 milligram per liter to 500 milligram per liter or even less than that. So degree of treatment means how much amount of treatment you are giving to the water so that all the water quality parameters falls within the permissible limit. I have just taken one example of total solid. Say this example is from river 1. Say this is my river 1, and in river 1 the quantity of total solid was 600 milligram per liter. So certain degree of treatment was given to this water. Say this degree of treatment is D1, right? And after giving this degree of treatment, now the quantity of total solid has reduced to 500. There is some river 2 which contains 700 milligram per liter of total solid. There is some river 2 which contains 700 milligram of total solid. Now obviously, if I have to bring down this value from 700 to 500, I need to give more degree of treatment. And that is how degree of treatment varies for every different source of water from where we extract. Different water extracted from different source will be subjected to different degrees of treatment. So when you travel across the country, different treatment plants will going to offer different degree of treatment, but their mechanism process can be same. Okay. So the degree of treatment given to the raw water depends upon two factors. First one is the existing quality of the raw water, and second one is the desired quality of the treated water. Desired quality of the treated water means permissible limit of water quality parameters. Permissible limits of water quality parameter. Desired quality of treated water simply means permissible limits of water quality parameter, and this we can very easily figure out that it is the existing quality of raw water. So the degree of treatment given to any raw water depends upon two factors. First one is the existing quality of raw water, and second one is the desired quality of the treated water. I have given an example of two rivers. For river 1, total solid concentration is 600 milligram per liter. So degree of treatment given was D1 to bring down this total solid concentration to 500. In river 2, the total solid concentration was 700 milligram per liter. So obviously, I need to give more degree of treatment to bring down this value of 700 to 500. So this D2, degree of treatment given to river 2, will be obviously more than degree of treatment given to water extracted from river 1. So this is how degree of treatment will going to vary. It is one of the very, very important and very frequently asked interview question. So please keep a check on this. Basically, if this question is asked to you in an interview, this question actually tells how much basic do you understand, how you have read the process. Have you only read the process, or even you have understood why we are doing the process? So that's why this is a very, very important slide, especially for the students who will be facing any kind of job interview. Okay, so the degree of treatment given to raw water depends upon two factors. First one is the existing quality of the raw water, and second one is the desired quality of the treated water. And desired quality simply means what are the permissible limits of the different water quality parameter. Now, one more thing again, in simple one line I will say this. Why we are giving treatment to water? We are giving treatment to water to bring the value of all the water quality parameter within the permissible limit. If any water quality parameter value in the existing quality is above or below the permissible limit, then we bring it to the permissible limit. That is why we give treatment to water. Now for giving treatment to water, we use different processes. First is known as screening. Screening removes the coarse suspended solids. Then we have aeration. Aeration removes some dissolved solids, taste and odor, color causing compounds, all those things. You can read this. Then there is coagulation and flocculation. Coagulation and flocculation does not remove anything. It basically agglomerates the fine suspended solids together so that they form the larger size particle. Then we have the process of sedimentation, which actually removes the core suspended solids. You allow the solids to settle down, and by this settling, these solids are removed from the system. Then we have filtration, softening and disinfection. So all these are the different methods by which we treat the water. Now based on the existing quality of raw water, these processes may change, right? But the sequence of this process is almost same. This softening is done along with coagulation and flocculation, but almost only these 7 steps are usually performed for treating the raw water. Our area of study is this, sedimentation. But before that, I would like to make one thing clear to you. Whenever you collect the raw water sample, say this is my raw water sample. Whenever you will going to collect this raw water sample, say this is my raw water sample. In this raw water sample, there will be 2 solids present. These are my suspended solids. These are my suspended solids. And then we have the dissolved solids like this. Then we have dissolved solids like this, right? Suspended solid will going to affect the physical water quality parameter. That is, suspended solid will going to affect the physical property of water. That is, appearance of water, how is it looking, all those things. And these dissolved solids will affect the chemical property of water. So this one thing is very clear, that suspended solids is removed by physical methods, and dissolved solids will be removed by chemical methods. Dissolved solids will be removed by chemical methods. Means we will going to conduct any chemical reaction, and using those chemical reactions we will going to remove the dissolved solids. Suspended solids will be removed by physical method. One of the physical method is settling of the solids. The second physical method is you provide some screen, right? And you allow the water to flow through that screen. Now this screen will not allow the suspended solids to flow through it, just like applying the filter paper, right? You keep the filter paper, and when you pour the water, when you have kept this filter paper and you have poured the water over it, all the suspended solids will retained over this filter paper. Now this mechanism is known as screening, means you have screened the suspended solids. You haven't allowed the suspended solids to flow through the filter paper. Okay. So suspended solids will be removed by the physical methods, and dissolved solids will be removed by the chemical methods. As simple as that. One of the physical method is screening. Then next physical method is sedimentation. And the third physical method is filtration. Means physically you are doing something with the suspended solids in order to remove them. Either you are restricting the entry of the suspended solids, or you are allowing the suspended solids to settle out. That is how we define the physical methods. Okay. So there are basically 2 types of solid in your water, and you need to remove both these types of solid. First one is the suspended solid, and second one is your dissolved solids. Dissolved solids will be removed by chemical methods, that is by performing any chemical reactions. And suspended solids will be removed by physical methods. That is, either you physically stop it from entering, or you just allow these solids to settle out and they will be removed from the system. Okay. Chalo, let's start with this. Now, my dear students, as I've already told you that there are two types of solids, suspended solids and dissolved solids. Right now, we will be only focusing on the suspended solids. Okay. So, these are my suspended solids which are present. These are my suspended solids which are present in my raw water. These are my suspended solids which are present in the raw water like this. Okay. Now, if I don't have to invest any amount and at the same time I have to remove all these suspended solids, then the best way to do it is you just allow these solids to settle down, right? You just leave this water for some time and allow this solid to settle down. Over the period of time, you will find out that these solids will settle down under their own weight like this. All of you might have done this. Whenever you have got some dirty water or the water containing solids, you have just left this water for some time, and in that time, these solids, suspended solids which are present, they will going to settle down under their own weight, and they will be settling at the bottom of this container. They will settle at the bottom of this container like this. They will settle at the bottom of this container like this. Now, can anybody tell me how this settling is happening? Or is there anything which is responsible for the settling of these solids? Is there anything that is responsible for the settling of these solids? So, first point is, the settling of this solid is taking place under its own weight. The settling of solids settle, suspended solids settles under their own weight. Suspended solids settles under their own weight. This is the first thing. Second thing, this theory of sedimentation is totally dependent on one factor or one parameter, which is known as the specific gravity. Okay. This entire theory of sedimentation, that is settling under its own weight, is dependent on only one parameter, and that is known as the specific gravity. The settling of solids depends upon only one parameter, that is specific gravity. That is specific gravity. The settling of these solids will depend on only and only one parameter, that is known as the specific gravity. Now, what is this specific gravity? A specific gravity is simply the ratio of unit weight of solid to the unit weight of water. A specific gravity G is simply the ratio of unit weight of solids to unit weight of water. It can also be taken as the ratio of density of solid to density of water. This water for us is the standard fluid, right? So, this is how you measure the specific gravity. The general formula for measuring the specific gravity is specific gravity G is equal to weight of solids, that is WS. weight of solids divided by the weight of standard fluid, weight of standard fluid of same volume as that of solids, right? So this is the most general formula for calculating the specific gravity. The standard fluid that we use here is the water, okay? So when you just write down this, so this weight of solid Ws divided by volume of solid, that is Vs, into unit weight of water, that is gamma W. Weight of solid divided by the weight of water having the same volume as that of solids. Now this weight of solids can be written as volume of solids multiplied by unit weight of solids divided by Vs into gamma W. So this Vs and Vs will going to cancel out, and you have the ratio of gamma S by gamma W. So from here, this ratio of specific gravity comes out. So G is equal to gamma S by gamma W. So the entire theory of sedimentation depends on only one factor, and that is known as your specific gravity. Only one parameter, sorry, not factor. The entire theory of sedimentation will depend on only one parameter, that is known as the specific gravity. So this is the thing, you can note this down. So if there are suspended solids, so suspended solids will going to settle under their own weight. And for settling of this solid, no cost is involved. That's why it is one of the most economical method of treating the water for suspended solids. You have to just leave this water for some time, or you need to just create the flow to be laminar. And in this laminar flow where hardly any turbulence is there, the solids will going to settle very swiftly, and they will be removed very easily from the system. This entire theory of settling of solids will depend on one parameter, that is your specific gravity G. Now next you have one more thing here. I think I have included here. Okay. So here only I will write down. These particles will settle with a constant velocity, which is known as the settling velocity of the solids. These particles will settle with a constant velocity, which is known as the settling velocity of the solids. These particles will settle with a constant velocity, which is known as the settling velocity of the solids. These particles will settle with a constant velocity, which is known as the settling velocity of the solids. The settling velocity of the solids is determined using Stokes' law. This settling velocity of the solid is determined using Stokes' law, right? Simple, very simple. Determination of Stokes' law we do when we take up the entire full length course, right? But since this is a foundation course, I just want you to have some basic idea that particles are settling under their own weight. And when these particles are settling under their own weight, they will settle with a constant velocity, and that is known as the settling velocity of the solids. This settling velocity of the solids is determined using Stokes' law. Simple. What is the expression, what all things are there, that is a separate part of discussion. Since this is the foundation course, we will just focus on some key areas. Particle is settling with the constant velocity, that is the settling velocity, and it is determined using Stokes' law. Now comes the next part of discussion is on which factors this settling of solids will going to depend. Okay, so one by one we will discuss all the factors which are affecting the sedimentation of any solids. So first factor that affects the settling of the solids is termed as the velocity of flow. My dear, just take this tank for an example. If the velocity of flow is very high, if the velocity of flow is very high, if this velocity of flow is very high like this, if the velocity of flow is very high, if the velocity of flow Vf is very high, if the velocity of flow is very high, then in this case the time available with the particle to reach from top to bottom of the tank is not there. The time available with the particle to reach from top to bottom of the tank is not there. And if the particle is not reaching the bottom of the tank, it is not removed. So if velocity of flow is too much, the time available with the particle to reach bottom of the tank is not there. Hence, the particle is not removed. So in simple words, if the velocity of flow is too much, then the settling of the solids will be less, because the time available with the particle to reach the bottom of the tank is not present. Second, if you have high turbulence of water, if there is huge turbulence present in water like this, if huge turbulence is present in water like this, now this turbulence lead to the production of eddies like this. This turbulence will lead to the production of eddies like this, and if the eddies are formed, again these eddies will hinder in the settling of the solids. These eddies will not allow the settling of the solids. These eddies will not allow the settling of the solids. These eddies will not allow the settling of the solid, rather they will send back these solids back to the settling zone. They will going to send back these solids back to the tank, right, from where they have started settling. So this, the primary example is whenever you see river water in rainy season, it is full of mud and dirt. Reason is, during rainy season, this water is having huge discharge. And due to this huge amount of discharge, so much turbulence is present in this river. And because the turbulence is more, therefore the settling of the solids will be less. On the other hand, if you observe the same river during summer seasons or during low discharge seasons, you will find out that these rivers are more clear. Reason is, due to less turbulence, most of the solids have settled very swiftly to the bottom of this channel. Similarly, in these tanks, if there is high velocity, two separate reasons. If velocity is high, then available time is not there. Available time is not sufficient for settling. 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 Second, if high turbulence is there, eddies will be formed, and eddies will hinder in the settling of solids. Eddies will hinder in the settling of solids. Eddies will hinder in the settling of solids. So in either of the cases, if velocity of flow is high or turbulence is more, the settling of the solids will be less. So you can write down, if velocity is high, if velocity of flow is more and turbulence is also more, turbulence is also more, then settling of the solids will be less. Then settling of solids then settling of solids will be less. Then settling of solids will be less. Okay. So the first factor that affects the settling of the solid is velocity of flow in turbulence. If velocity of flow is more, then the available time for settling is not there. And if turbulence is more, due to the production of eddies, these eddies will hinder in the settling of solids and will not allow these solids to settle properly. Okay. So in both the cases, your settling of the solids will be less. So this is the first factor which affects the settling of the solids. Now comes the second factor. The second factor which affects the settling of the solid is viscosity of the fluid. Now see this, my dear student. This is your first tank. This is your tank 1. This is your tank 1, right? It is filled up of honey. And then you have this tank 2 which is filled up of water. This tank is filled of water, right? This tank is filled of honey and this tank is filled of water. Which fluid has more viscosity, honey or water? It is filled up of honey. This tank is filled of honey and the other tank is filled of water. This is honey here and then this is water. For which fluid viscosity is more? So obviously honey is more viscous than water. Okay. Now you observe this very carefully. This is my solid which is settling in both the tanks. This is my solid which is settling in both the tank. Same solid which is settling in both the tank. It is settling in honey and also it is settling in water. And this solid is settling with a constant velocity, that is the settling velocity Vs. That is the settling velocity Vs. Now you see this. When this solid is settling in honey, on the surface of the solid, honey will apply the frictional resistance like this. Honey will apply the frictional resistance like this. This is the friction offered by honey. On the same way, when this solid is settling in water, water will also apply the frictional resistance on the surface of this solid. So this is the frictional resistance which is offered by water. Now when we talk technically, we say that it is the drag applied by water on this surface of solid. Okay, but we will not go technically, we will just going to understand it in form of very basic. So when the solid is settling in honey, on the surface of the solid, honey will going to apply the frictional resistance and will not allow this solid to settle down, right? That is how the thought process of honey goes. And same, the thought process of water goes in the same way. When this solid is settling down, water will going to apply the frictional resistance and will try to pull up this solid. Okay. Since the viscosity of honey is more than the viscosity of water. Viscosity of honey is more than the viscosity of water. Therefore, the frictional resistance applied by honey will be more than the frictional resistance applied by water. Therefore, the frictional resistance applied by honey will be more than the frictional resistance applied by water. And if the frictional resistance applied by honey is more, it means the settling of the solid in honey will be less. If the frictional resistance applied by honey is more, it means the settling of the solids in honey will be less. So more the viscosity of the fluid, less will be the settling of solids. More the viscosity of fluid, less will be the settling of solid. Let me just keep this. More the viscosity of the fluid, less will be the settling of solids. more the viscosity of the fluid, less will be the settling of solids. So this is how it goes like. So this is the second factor which affects the settling of solid. That is the viscosity of the fluid. If viscosity of the fluid is more, then the settling of the solid will be less, because more frictional resistance will be applied by the fluid over the settling of the particle. The third factor that affects the settling of the particle is the size of the particle. Now, my dear student, first of all, for comparing this factor, first thing is, you are comparing you are comparing particles of different sizes which are made up of same material. You are comparing settling of different particles which are made up of same material. And if all these materials are same, it means all these materials will have one value of G. Means for comparing the size of the particle, first you need to make sure that specific gravity is constant. That specific gravity is constant. Specific gravity is constant. Means all these solids have same value of G. All these solids have same value of G. If solids have same value of G, now as the size of the particle will going to increase, the settling velocity of the particle will also going to increase. So this is Vs, this is Vs dash, this is Vs double dash, and this is Vs triple dash. So clearly, as the size of the particle is more, the settling velocity of the particle is more. So this is the order of settling velocity. If the settling velocity of the particle is more, it means more settling of that particle will take place. So if you are comparing 4-5 different types of solids, first thing is you make sure that these solids have same value of G. If these solids have same value of G, then only with increase in size, settling of the solids will also increase. So if the specific gravity is constant, then more the size of the particle, 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 more will be the settling of solids. More will be the settling of solids. More the size of the particle, more will be the settling of solids. Now you may think, sir, ki why I have fixed this specific gravity to be constant? Then I have compared this. Now you take another example. You take two different materials, okay? Right now all these materials are same. All these materials are same, only sizes are different. All these materials are same. All these solids are made up of same material. All these solids are made up of same material, right? Now, for example, you take two different material. Very carefully understand this, what I am telling you. Now you take different material. Say this is your tank which is filled of water. Both the tanks are filled of water like this. Both of them are identical tanks, right? In one of the tank, you have dropped a feather of this size. This is a feather, right? This is a feather. You have dropped a feather of this size. And in the second tank, you have dropped a stone of this size. This is a stone, this is a feather, right? Obviously, specific gravity of stone is more than the specific gravity of feather. You can clearly identify that this feather will not going to sink at all. On the other hand, the small size of stone, as soon as you will going to drop it, it will going to sink inside the water, right? So, for different materials, we cannot directly compare whether if size is more, then the settling of the solids will be more. So first you need to make sure that specific gravity of all the solids is same, then only you can compare the settling of the solids with respect to the size. So for this feather, even the size is more. For feather, this is a feather. And this is a stone. This is a stone. So G of feather is less than G of stone. But size of feather is more than the size of stone. So even if the size of feather is more, it will not going to sink at all. But on the other hand, for the stone, even if the size is less, it will going to sink properly. So just converting this larger conversation into one single line, that is, if you need to compare different particles with respect to sizes and you need to comment something on the settling, first you need to make sure that all these particles are made up of same material, that is, they have the same value of G. If they have the same value of G, then only you can compare it with respect to the size of the particle. So if these particles have same value of G, then as the value of size will increase, more will be the settling of solids, in simple words. So there are basically three factors which affects the settling of the solids. The first factor is termed as your velocity of flow and turbulence. Second one is the viscosity of the fluid, and third one is your size of the particle. You can just note this down. Just give me 1 minute. Chalo, moving on to the most important discussion for sedimentation. Now, my dear students, the sedimentation of the solids is carried out in units which are known as the sedimentation tanks. The sedimentation of the solids is carried out in units which is termed as the sedimentation tanks. These sedimentation tanks are of two types: quiescent type, fill and draw type, or continuous flow type sedimentation tank. So I'll write here. Sedimentation is carried out in units termed as sedimentation tank. It is carried out in units termed as sedimentation tanks. These sedimentation tanks are of two types. So next is types of sedimentation tanks. Types of sedimentation tank. So first type of sedimentation tank is known as fill and draw type sedimentation tank. Fill and draw type sedimentation tank, and the other name for this is quiescent type sedimentation tank. Quiescent type sedimentation tank. So sedimentation tank is carried out in units which are known as the sedimentation tank. The first type of sedimentation tank is known as fill and draw type of sedimentation tank or quiescent type sedimentation tank. Second type of sedimentation tank is known as continuous flow type. Continuous flow type sedimentation tank. Now this continuous flow type sedimentation tank is also further divided into two categories based on the direction of flow. If the flow is taking place in the horizontal direction, it is known as horizontal flow type continuous sedimentation tank or horizontal flow type tank. Horizontal flow type tank. And if the flow is taking place in the vertical direction, it is known as vertical flow type sedimentation tank. It is known as vertical flow type. It is known as vertical flow type sedimentation tank. So sedimentation tanks are of two types, fill and draw type sedimentation tank or quiescent type or continuous type sedimentation tank. Again, depending on the direction of flow, these tanks are further of two types, horizontal flow type tank and the vertical flow type tank. Now next is, there are different components, right? Basically, if I have to design a sedimentation tank, right, I have to design different components of the sedimentation tank. You see this. Designing the sedimentation tank means designing the components of the sedimentation tanks. So you see this. So next is design of, or first you see the components of sedimentation tanks. So this is my normal tank, okay? This is my normal tank. For this normal tank, there are two partitions. This upper partition is known as the settling zone. This is known as the settling zone, where the settling of the particle takes place. This is known as the settling zone, where settling of the particle takes place. The second one is known as the sludge zone. This one is my sludge zone. This one is sludge zone. This one is my sludge zone, okay? This is the height of the settling zone, and this will be denoted by capital H. This is the height of the settling zone denoted by capital H. Now from here onwards, you need to be very clear in your mind, okay? From this end, the flow will take place inside the tank, right? Or for now, this one is fine, right? And this is the length of the tank, L. This is the length of the tank, or I should say design length of the tank. I'll write here. H is design height of settling zone. And L is design length of settling zone or settling tank. Okay, so this is the thing. Now this data is common for any type of tank, whether it is fill and draw type tank or it is a continuous flow type tank. This data is common for everything. Okay, but again there will be change in this data as you change the type of tank. So you read about different design components of these tank when you read individually about all these different types of tank. What today's session we will concentrate more on this horizontal flow type, continuous horizontal flow type tank. Simple. This is one of the key area from where you will get questions. Horizontal flow type tank. So my next discussion will be concentrated purely for this horizontal flow type tank. Okay, so you are clear on the different components of the tank. So components of sedimentation tank include the settling zone and the sludge zone. Capital H will be the height of the settling zone and L will be the length of the settling tank. Okay. Now if I precisely talk about this horizontal flow type tank, if I precisely talk about the horizontal flow type tank, the first assumption that we take in analysis is concentration of particles of all the sizes is same at all the points of the vertical section of the inlet end. Now here most of the student has confusion. Reason is what they read and what they imagine in their mind is this. I'll draw it in the next slide. Usually this is taught to them. This is taught to them. Just see the visualization, right? One tank I have drawn in front of you. The water is entering into the tank like this. It is flowing like this. And it will flow out like this. This is usually what is taught, and this is the thing which creates confusion in their mind ki how you are saying that at the inlet end the particle size concentration is same at all the heights. Okay, because all the particles are entering from this point. This is the point of entry. So forget about the inlet section, this vertical plane. All the particles will be present here itself. There is no point that the particles will be present here, right? Now how the particles are present here, how we will going to analyze this? So this is the thing that comes up. So my dear students, tomorrow we will going to see this entire analysis. I was like thinking that this entire thing will be completed today itself, but again this is a discussion of 1 hour. So today I am going to conduct another session and that will be totally dedicated for this analysis, right? So I'll see you tomorrow, same time, same place at 3 p.m. on IMS Gate Academy YouTube platform. Thank you so much for today. Have a great day ahead.